Okay, I will just discuss Lab 3. So this is Physics 101. Lab 3, and I'm talking only about case 1 here. So the idea is that you have a ring in the center of your turntable, and in the center of this ring there's a little pin, and you apply 3 forces, and if the forces are perfectly balanced, then the ring doesn't touch the pin. Now, the first force points in direction 0, so I'm labeling this direction as 0 degrees. Then we have 90 degrees here, 180 degrees here, 270 degrees here. So that's our reference frame. So F1 is 100 units strong, and I'm not worrying about units here, I'm just calling it, an arbitrary unit of 100, and the angle theta 1 is 0 degrees. Now, we're told that there's a second force that's stronger, and that points in the direction 120 degrees. So this is F2. Theta 2 is 120 degrees, and the magnitude of F2 is 150. Now we have to apply a third force, some unknown number, F3, and we want to know F3 and theta 3. And the whole trick of the calculation here is that you can consider the forces acting in the y direction. Let's call this y and this x. You can consider the forces acting in the y direction separately from the forces acting in the x direction. And each of them separately have to cancel out, add to 0. Because if they don't add to 0, then our circle would not be balanced around the center. So let's consider the x direction first. Well, the x component of F1 is 0. It doesn't exist because F1 just points along the y direction. The x component of F2 is the component pointing along the 90-degree angle of this force F2. And from simple trig, we know that x of F2 is 150 times cosine of 30 degrees. You'll find is 130. So 130 is the only force acting in the x direction before you apply your force. So your force, in order to balance this out, the x component of F3 has to be minus 130. Now a little more complicated is the y component, right? How much do we have to pull downward to balance the other two forces? So let's consider the y direction. The y component of our force F1 is 100. And the y component of our force F2, well, it's this quantity here, which is just from trigonometry 150 times sine of 30 degrees. And that is 75. But since we're going in the negative y direction, it is minus 75. So my y component of F3 has to be minus the sum of the other two components. So minus y of F1 plus y of F2, which is minus 100 minus 75. So it's minus 25. So our F3 has two components, namely minus 130 in the x direction and minus 25 in the y direction. And you get the magnitude from Pythagoras. The magnitude of F3, the length of your vector F3, is just the square root of the sum of the squares of the two components. So it's minus 130 squared plus minus 25 squared, which is 132. Now, what about the angle? Theta 3. So let's call this here is theta 3. And from trigonometry, we know that the arctan of minus 25 to minus 130 is this angle, theta 3. Actually, let's call it theta 3 dash. And that is just about 11 degrees. And why do I call it theta 3 dash? Because the actual value I was looking for is this angle. And so I know that the angle theta 3 is 270 degrees, here, 270 degrees, minus theta 3 dash. So that's 270 degrees minus 11 degrees is 259.